Our next topic is going to be dealing with complex rational expressions. These are where we're going to actually be combining all of the ideas we've dealt with, adding, subtracting, simplifying, and multiplying, and dividing, into a single problem. So we get, in order to do this, we're going to look at fractions inside of fractions and figure out how to deal with those. So we'll be combining a whole bunch of things here. Now we keep them kind of basic. These could get ridiculously large. We could have fractions inside of fractions inside of fractions and so forth. But what we're going to do is just kind of keep it basic, give you the general structure and idea behind how to solve these or simplify them. Okay, so just a quick idea, if we had just complex fractions, just a regular fraction numerically inside of another fraction, something like 2/5 divided by 4/3. This is a fraction inside a fraction. Actually, there's two fractions inside of a fraction. So this would be considered a complex fraction. To simplify this, remember that the main fraction here is really a division. Fractions and divisions are the same thing. And so what we're really looking at is 2/5, the top fraction, divided by 4/3, which is the bottom fraction. And so remember, with dividing fractions, it's equivalent to multiplying by the reciprocal. Okay, we dealt with that when we did the dividing of rational expressions a few sections ago. So here we're going to do the copy dot flip, as I call it. Copy the first, change this to multiply, and then flip the second fraction. So you're multiplying by the reciprocal. So I'm going to write this as 2/5 times 3/4. Again, you flip the second fraction, or in this case, the denominator. Now you wouldn't have to write this middle step out if you were comfortable with just noticing this as a division, and then just flip that second or that bottom fraction to get your reciprocal. You could just jump right to the multiplication. Simplify here, the 2 with the 4, and then multiply across, you get 3/10. Okay? Now we can do the same sort of process with rational expressions instead of just numerical fractions in the complex fraction there. So let's kind of repeat this process. Something like 2/x divided by 5/x squared. Okay, so again, now I'm going to skip that first step where I rewrite it as a division, because we already know that that's going to be the case. So let's just do the copy dot flip right off the bat here. Let's take the top, we'll copy it, change the divide to a times, copy dot, and then flip this bottom fraction. So we get x squared over 5. Then we reduce whatever is common to a numerator and denominator. Here we've got an x that's common to the top and bottom. I'm going to reduce one of those out, and I'll be left with a 2x over 5 as a simplified form. Okay? So not too bad. You're really just converting this fraction into a division and then copy dot flip to change it to a multiplication. Where it gets a little bit tougher is when we start to add more things to the numerator and denominator. Maybe having to add or subtract inside of each of those. To give you a quick example, something like 1/x plus 1/2 divided by, let's go with 2/x minus 1/2. All right, so here's an interesting example. What I'm going to need to do is to add first on the numerator and do the subtraction on the denominator using common denominators to get those together. And so the first thing I would do is I might take these off to the side and work them out, just so it's a little bit more clear what's going on. If I take that first combination here, the numerator, 1/x plus 1/2, the LCD there is 2x. And so I'm going to multiply by the missing factors. In this first fraction, I need to multiply by a 2. And in the second fraction, I need to multiply by the missing x. Then I multiply together, I get, what's this, 2/2x. And here I get x over 2x. And when I combine them, I get 2 plus x over 2x. They have a common denominator, okay? So that becomes my new numerator. That's the combination of those two. So it's 2 plus x all over 2x. So what I've done is I've taken two fractions, turned them into one. I'll do the same on the bottom and then do the copy dot flip. Okay, so on the bottom, I'll take those off to the side here as well. 2 over x minus 1 over 2. Again, the LCD is 2x. So I'm going to multiply by the missing 2, multiply by the missing x. And let's see, this gives me 4 over 2x minus x over 2x. And then combine those into one fraction, 4 minus x over 2x. That becomes my denominator. So I put that in on the bottom, 4 minus x over 2x, and then do the copy dot flip. Okay, so think of this as a division problem. We're going to do, let's rewrite that. So first fraction or top fraction is 2 plus x over 2x. Then remember we multiply and then flip this bottom fraction. So it's 2x over 4 minus x. Then we reduce anything that is common to the top and bottom. I have a 2 and an x and a 2 and an x. All those cancel here. So the 2 cancels, this x cancels. Those are common factors. On the bottom, on the top, I'm left with a 2 plus x, and the bottom it's a 4 minus x. And so those don't simplify because they have no common factors. Right? I can't factor these out. They are not the same thing. And so this is as far as we can go. So 2 plus x over 4 minus x is our final simplified answer.